Okay, so we are going to go over the 3 types of notation that we'll be using the most often in class. So we have set notation, interval notation, and function notation. Okay. So to start off with set notation. Set notation is what you've been doing right now. So set notation with discrete relation is what your do now is over, right? And it's just simply listing out. So you're creating a list and it's from least to greatest, right? Okay. And typical set notation, there is no repeating. So here, our domain are our x values. Our x values are the even numbers. So we list out 2, 4, 6, 8. Our range are our y values. So we have 3, 5, 7, and 9. So that's our discrete data. That's our set notation for discrete data, which is what we've been doing, right? Okay. Now we're going to talk about continuous relations. So if you have a continuous relation, that means that there are infinite amount of numbers from one point to the other, and there's no way that you can list them all out. Okay. And so when we're doing this, we utilize our inequality symbols. And how we know which inequality symbols to use, it depends on our endings. So notice here, I have an open circle. And because it's open, that means I'm either going to be using less than or greater than. So here at -3, 0. Here at 1, -4, it's a closed circle. It's closed, which means that I'm going to be using less than or equal to or greater than or equal to. Okay. When we're writing continuous relation, I just want to point out really quick that this is actually a continuous function. And I can tell that it's a continuous function. Does anyone remember what that test is called? To tell that it's a continuous function. It's a line. It's a vertical line test, right? So the vertical line test tells me that if I have a vertical line, and as I move that vertical line, it only hits one point at a time, that means that this function is, this relation is a function. Okay. So yes. So do we see this? So we know that this is a function because it passes the vertical line test. Remember that vaguely? All right. So not just a relation, but this is a function. And that's because it passes the vertical line test. So when I call it a function, don't freak out on me. So when we're finding the domain of this function, we're going to use, you have to use braces. So we use our braces. And I know this is like a capital bold I, but it's not. It's called a such that symbol. Okay. Because what we're creating is a mathematical sentence. So we have the braces, and this is saying X such that X is blah, 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 blah. Okay. And you read it from the middle. So X is, so when I'm looking at my X values, I see that my X's lie between -3 and 1. Do we see that? So X is less than or equal to 1, but X is greater than -3. Do we see that? So X is greater than -3, but X is less than or equal to 1. Because that's the X value. It's your smallest X value. Yeah. Yes. So when you're writing a compound inequality, you're always going to either be using less than symbols because you're defining X because it's sandwiched in between. Because it's in between, right? So either I have to be bigger than one number and smaller than the other. And if I use any other, then I end up contradicting myself. Okay. Okay. So right here, again, this is a math sentence. It's saying x such that x is greater than -3, but less than or equal to 1. So any value that fits that is defined in my domain. All right. So let's talk about our range. So our range is from bottom to top, right? So from bottom to top, y such that y is what? What's my lowest y value? -4. It's less than or equal to -4. Why is it less than or equal to? Because it's closed at 4, right? And I'm closed at 4, so I have to be equal to, not just less than. And what is my highest y value? My highest y value is 0. 5's not even on the y-axis. Okay. Highest y value is 0. And the thing is, it's a little tricky. I'm open at -3, but notice here at 0, I'm what? I'm closed. As long as I'm closed at one location, then it's going to be the less than or equal to. No, it's a continuous point. So they're all connected. It goes through 0. I printed the graph. Okay. Hey guys. So really quick, is there an obvious hole here? No, this is a continuous function. There's no hole at 0. A graph is made up of a bunch of points, right? Connected together. So it's not going to be a super big obvious point because it's not the ending of it, but it's just a bunch of points all connected. So that's why I took the pen to remind y'all that here, the origin is there and it's closed. So that's why it's less than or equal to 0. As long as I'm defined at one point, then I'm part of the range. All right. It's one flat. 10. 10. Yes, deliberately. Okay. So interval notation. When using interval notation, what we're doing is we're going from using our inequality symbols to using parentheses and or brackets. So when we have strictly less than or strictly greater than, we're going to end up using parentheses. And what that means is that it's not included in my domain or in my range. And graphically, there is some type of discontinuity, usually an open circle. Okay. If I have less than or equal to or greater than or equal to, I'm going to be using brackets. And what this means is that it is included. And graphically, I have a included point, a closed point. No matter how tiny the closed point is, it's closed. Okay, just so you knew the importance of it. Okay, when using the infinity symbols, you're going to always use parentheses. Okay, and that's because can you contain infinity? No, you cannot. So it can't be included if you can't contain it, right? All right, so we're going to take the function that we used at the top, and we're going to define its domain and range using interval notation. So above, we said that our domain was from -3 to 1, and our range was from -4 to 0, right? So going from interval, from set notation to interval, you're paying attention to your inequalities. So I have a less than inequality. So what type of ending am I going to have? We just said, if I have less than, then it's going to become what? What are these called? It's open. And what are these symbols called? Parentheses. So at -3, I'm going to put a parenthesis. Okay. At 1, what do I have? I have less than or equal to. So at 1, it's going to have a bracket. So I call interval notation lazy math man, because they got tired of writing this. So they're like, well, how can we shorten this? How can we eliminate some characters? So they brought in parentheses and brackets and called it a day. All right. So with that same token, what would my range look like? So this was the range up top. What would it be in interval notation? It will be bracket followed by, and what's my second inequality? Another, so it would be another bracket. And that is your interval notation. So that's how you would go from set to interval and vice versa. So one is shorthand and one is not. All right, function notation. So our last type of notation is function notation, okay? When you have multiple relations or functions, you typically name them different things, right? So have you ever seen f of x, g of x, h of x? Because we have more than one. So basically for f of x, what that means is plug in for x, right? When you see f of x, that means you're plugging in something for x. And when you're reading this, it's f of x. It does not mean you're multiplying anything, which is one of the biggest misconceptions I hear people, they try to multiply. What am I multiplying this? Nothing. It's just f of x, okay? F of x equals y. It's just another way of representing y. And therefore, I can go from function notation back to ordered pair simply by stating my x and what it's equal to. That's all function notation is. Okay. So let's do an example of function notation. So if given y equals 2x plus 3, write in function notation, it literally means that I'm taking my y and getting it dressed up, making it fancy. So it becomes f of x. That is all it's wanting you to do. If it's saying to represent it in function notation. It's like writing formally in mathematics. Okay. Now it says for us to evaluate using function notation. So we know x equals 2. So that means where x was, it's now going to become a 2. So we have f of 2 equals 2 times 2 plus 3. What is 2 times 2? 4. Glad I got a whole crowd participation there. What is 4 plus 3? Now 7. So f of 2 equals 7. So this is my result in function notation. I can write this as an ordered pair by writing 2, 7. So those are our 3 types of notation: set, interval, and function notation.